All right, everybody, we're going to get started on our exponential functions review for your quiz today. So you'll see that we have five different questions. 3 of them are going to be the exponential functions that we're solving. 2 of them are our exponential graphs. So let's take a look here at our first question. I'll only do one of these because 3 of them are all the exact same. So there's no point in me going through 3 questions for the same work. But we'll take a look at one of these first. So this one is that we have $1,600 placed in an account with an annual interest rate of 5.25%. How much will be in the account after 25 years to the nearest cent? So reading through these pieces in our question here, we first need to decide, is this problem talking about exponential growth, exponential decay? Are we talking about getting more money, or are we losing value? So when we read through this, we're talking about placing money into an account. Well, if I'm putting money in an account and I'm going to lose money for saving it there, I probably don't want to save my money there. So we know that this problem, whenever we talk about our annual interest rate, that problem is going to be talking about growth. So this is a growth problem for us today. Now, you may need to use your notes to look back and see if you don't have that equation memorized just yet. Our growth equation is y equals a times 1 plus r to the t. But we need to figure out what all of those pieces mean for our equation. So we want to have our a, r, and t. We have those 3 pieces. We want to figure out what those are for our problem here. Well, let's start off maybe with time. Whatever time increment we're talking about, whether it's seconds, minutes, days, years. So let's read through this question again. We have some money that we're putting into an account with an interest rate of 5.25%. How much will be in the account after 25 years to the nearest cent? Well, we know that there was only one thing that talked about any sort of time increment, and that's this 25 years. So we see 25 years. So we'll say t is 25. So when we fill in our equation here, we'll have 25 as an exponent. Then, whenever we want to find our rate of change, we're looking for whatever has a percentage sign. And we're going to take that percent and convert it into decimal form. And remember, there might already be a decimal in that percentage. So that means we're going to take that decimal and move it 2 places to the left, or we're going to divide that number by 100. So when we read through here, the only thing that has a percentage sign is our 5.25%. 5.25%. But we need to convert this, move our decimal over 2 places to the left. So we get 0.0525. So in our problem here, we'll have 0.0525. And we can fill in the generic parts of our equation. And so the last thing that we'll need to fill in here is our a. What is our a? Well, a, remember, is our initial value. It's our initial value on these. So when we take a look here, our initial that we placed into our account was 1,600. So over here, we'll put 1,600 in our equation. So we have all of those pieces there together. You can either use your calculator that you have on your Chromebook to type this in, or you can use the handy little calculator right up here on Delta Math. When we use this calculator, it's going to look maybe a little bit different, maybe a little bit the same. So we're going to use our keyboard here and type it in just like we have been. We don't need the y equals portion of our equation because the calculator doesn't know what it means to have a variable. So for our calculator, we'll just type in the numbers, 1,600, parentheses, 1 plus 0.0525, and our parentheses. And to get an exponent, we use Shift 6 on the keyboard. You could also use this A to B button down here, that A to B. That gives us the option to type in whatever we want for our exponent. And our exponent for this problem is 25. Now, if I move my camera here, you'll see that we have an answer right here of 5,750. So we have 5,750. And then we have a long decimal, 0, 6, 2, 8, 9, 8. But we don't want to type in this full decimal. We have to round for the appropriate values of our problem. When we read through this, the last thing that it says is that we need to round our equation answer to the nearest cent. So we know that cents is going to be 2 decimal places. I'm going to look at this 2. 2 is going to be what decides if I round that 6 up to 7 or if I leave it. And since 0 to 4 is leave, 5 and up means we round it up. We know that we would just omit or get rid of that 2898, and our final answer here would be that y equals $5,750.06. So that's a pretty good game for our account there. Now, again, we have a few of these problems that we could go over. However, I'm going to jump to the next example of what type of problem we'll have in our quiz for today. So if we come back, question 2 and 3 will be the same type of problem as before. We're trying to decide if it's growth or decay. Remember that a decayed equation is going to be y equals a1 minus r to the t. So instead of adding, we are losing our rate of change every time. So we want to make sure that we use that for our equation. Just as a quick note there. Now, our next two questions, questions 4 and questions 5, are going to be looking at how do we graph these exponents. Now, remember that whenever we have our equation, we always want to do asymptote as horizontal, never vertical. This is always horizontal for us. There will be times in the future where we have vertical, but not today. So now we have our equation 2 times 2 to the x. And we know where to put our asymptote by whatever is added on to the end of our equation. There is nothing added on to the end of our equation, so we know that we are adding 0. I'm going to take this orange dotted line and move it up to 0. Now, the next part is the part that some of us really struggle with, which is filling in our H chart and understanding that when we plug in a number for x, we get a number out for y. That's our coordinate point. So let's talk through that. For this one, we are either going to plug in -1, 0, or 1. We can type in all three, though, just to see the different type of answers we're going to get. Now that we have this here, we're going to fill in when I plug in -1 for x. I have 2 times 2 to the -1. 0 is 2 times 2 to the 0, and 1 gives us 2 times 2 to the 1. So let's take our calculator and type these in. Now we're going to type these in exactly as they appear in our chart. So the first one I'm going to do is for -1. So when I have 2 times 2, and remember we changed our exponent now. It's not x, it's -1. What happens when I plug in -1? You see that I get 1 for an answer for y. Now the trick here is that 1 tells me that my equation has the point -1, 1. If it helps you to write out that coordinate point after we've solved it, then you can make that coordinate point. The next thing we're going to do is we're plugging in 0. So instead of hitting enter here on this equation, I'm going to come back into my calculator. I'm going to arrow over to -1, erase it and type in 0. So if you don't hit enter in this calculator, you'll always be able to go back and retype what you want to change. So we changed our exponent to 0, and when we change it to 0, we get 2 for y. That tells me my coordinate point is 0, 2. The last one is what happens when I have an exponent of positive 1. When my exponent is positive 1, I see that I get 4 out for my answer. So my coordinate point here is 1, 4. So we found our points that we want to use for our graph. So let's take and change what our points are. Remember, I plugged in -1 for x. I got 1 out for y. So when I plugged in -1, I would have this point here. You can put the other point right on top of it if you want, if that helps you. -1 up 1. We could pick any of these other 2 points here. I'll just pick 0. So when x is 0, I don't move left or right at all, but I do move up 2. I got 2 out for y when I plug 0 in for x. So I'll move that second point up 2 from 0. Again, we could have taken this other point here and said that I have 1, 4, So from the coordinate point 0, 0, I go to the right 1 for x and up 4 for y. Either way that we do this, we would see that we get our graph curving here. And as we look at our curve, as we move to the right, it moves up. And that tells us that this would be a growth. So when we take a look at our base on x here, we see that we have 2 as our base. We said that if that base is going to be greater than 1, we know that this is a growth function. Hopefully you were following along and writing down these problems. That way you'll be able to be more successful on your quiz. Good luck with your quiz.